Let's do section 10.5, page 528, exercise 27, which reads, determine whether the series converges absolutely, converges conditionally, or diverges. Give reasons for your answers. And for exercise 27, our series is the summation from n equals 1 to infinity of negative 1 to the n plus 1 times n factorial over 2 to the n. Now there are probably several different ways to solve this, but I'm going to try the nth term test. And just to remind you, the nth term test says that if the limit as n goes to infinity of the nth term, an, is not equal to 0 or fails to exist, then the series from n equals 1 to infinity of an is going to diverge. Now, if I start by testing for absolute convergence, then when I apply my nth term test, I'm going to take the absolute value of my nth term. So I'm going to start with the limit as n goes to infinity of the absolute value of an. And when I substitute in for an, I will have the limit as n goes to infinity of the absolute value of negative 1 to the n plus 1 times n factorial over 2 to the n. Now when I take that absolute value, that means that that negative 1 to the power term is going to go away. So this is just going to be the limit as n goes to infinity of n factorial over 2 to the n. And let's just write out a few terms of this and see what it's going to look like. So this is going to give me the limit as n goes to infinity of n over 2 times n minus 1 over 2 times n minus 2 over 2 times dot, dot, dot times 3 halves times 2 over 2 times 1 over 2. Now I can do this because there are n factors of 2 in the denominator and there are n terms in n factorial. So I can put each term of that n factorial and divide it by 2. Now my gut says that this should diverge, but why? Well, let's try to use the direct comparison test and see if we can find a function that we know diverges that is going to be smaller than our series in question. So I know that each one of these terms in the middle here is going to be bigger than 1. So I can say that the terms of my series, which is n factorial over 2 to the n, is going to be greater than or equal to n over 2 times 1 times 1 times 1 times 1 all the way down to a half. And that means then that I can take the limit of this series, and I'm going to get the limit as n goes to infinity of n over 2 times 1 times 1 times 1 dot, dot, dot times 1 times a half. And this, if I simplify it, is really going to give me the limit as n goes to infinity of n over 4. And this pretty obviously diverges. But because each term of my original series is bigger than each term of my diverging series, that tells me that my original series up here is going to have to diverge as well.